Hello and welcome back to the lecture on applied econometry.
We have been talking about instrumental variable. In the previous lectures, what you have seen is the problem of endogeneity. We talked in detail about the simultaneous equation bias problem. We have seen how instrumental variable can come to rescue in all these different cases of endogeneity. And then we actually talked about different types of instrumental variable strategy that we might have to face, and we might have to get rid of situations like bad IV or weak IV, and we'd rather prefer to have a good IV. Now, in this lecture, we are going to talk about another property of instrumental variable, and that is called identification property. Now, identification could be of three types. It could be over-identification, under-identification, and exact identification. Now, what I mean by all of this? Let's begin with the exact identification. Now, exact identification is something that we've already seen. So let's say we have one endogenous variable, exact identification. Let's say we have one endogenous variable, and that is, let's say, our x, and our instrument is z, and x is, let's say, I have some h, z, and some error term. Okay, so I have one endogenous variable, and I have one instrumental variable. Okay, so let's say if my number of endogenous variable is m, let's say this is number of endogenous variable, and if my number of instrument is equal to, let's say, n, so then in case of exact identification, what I'm going to have, m is equal to n, where n is number of instruments. All right. Now, in this equation, we can see I have one endogenous variable, that is x, and I have one instrumental variable, that is z, and basically my number of endogenous variable is equal to number of instruments. So this is a case of exact identification. Now, from this definition, we can clearly make sense what could be a case of under-identification and what could be a case of over-identification. So when we say over-identification, so in that case, what I'm going to have, I will have more instrument than my endogenous variable. So I'm going to have my m less than n. I have more instrument for my endogenous variables. Okay, and under identification, quite obviously, is going to be this reverse. Under identification, it is going to be m greater than n. All right. So an example of over identification, let's say I have a variable x, and I have, let's say, two instruments, which one, h1 z1 plus h2 z2, and let's say some gamma prime. Whereas for under identification, I do not have, let's say, any of this instrument. So if I have an endogenous variable that does not have an instrument, that is a case of under identification. Okay, so let us elaborate with all these different cases with an example. An example that we have already seen. Let us think of the example that I have previously done, where we talked about the price rate is equal to beta 1 plus beta 2 wage rate, and then I have an error term up. Okay, small up. And then we also wrote a wage rate equation, and wage rate is equal to alpha 1 plus alpha 2 price rate plus alpha 3 unemployment rate, and we had a UW. Okay, so we explained this P and W, they are basically endogenous variable in these two equations, and if I want to get an equation for P, so what I can do, I can actually substitute W here from this equation, and then what I can get in the equation of P, I can get a U, right? So P could be expressed in terms of UP, UW, and capital U. So this UW and capital U are coming from this W, right, which is an endogenous regressor, and UP is already present in this regression equation. So from here, since U is an exogenous variable, and since U is not related with the UP term, so covariance of U and UP is going to be 0. So basically, I can use U as an instrument. And in this equation, I have W and U, they are correlated, of course. So basically, covariance of U and W is not going to be 0, so that would satisfy the properties of IV. Now, that's all good. But if I think of this equation, let's say this is equation 2 and the first one is equation 1. If I think about the equation 2, so for here, if I actually substitute with this p from this equation. So what I'll get w in terms of, I will get up and uw, right? Up and uw. And of course, I will have my u, which is already present in my w equation. So what I'm getting here is up I'm getting instead of p, because that I got from this equation. And I do not have any exogenous variable here. I only have one exogenous variable, which is u, capital U. But that exogenous variable is already present in the model, in this equation of w. So I cannot use u again as an instrument, right? Because w is present, u is present, so not w, u is present in this equation on its own right, right? So if I again use another u, so what is going to happen is we're going to see the problem of exact collinearity. So we do not want that. If same variable is repeated twice in the regression equation, we are going to have the case of exact collinearity. So we cannot use u as an instrument when u is already present in the regression equation. Okay. So this is a case of under-identification. This is a case of under-identification. Whereas the first one here is the case of exact identification. And this is the case of exact identification. Now from here we can actually make sense what could be the case of over identification. So for that, let me actually write down another equation. And this is going to be a little change, little variation in equation 2. I'll rewrite the equation 2. Let's say I write w wedge rate is equal to alpha 1 plus alpha 2 p alpha 3 w. Let's say now I get a alpha 4, and now I use a money supply rate m, okay, and now my error term, let's say uw prime, okay. Now what is m? M I claim is an exogenous variable because m is basically the money supply rate. So when I'm basically talking about the money supply rate, what happens to wedge rate? So money supply rate is something that is exogenous because it is basically controlled by Reserve Bank of India in the context of India. And money, when money is supplied in the economy, so let's say money is channeled through different organizations and a part of the money goes in the form of wages. So when money is pouring into the economy, there will be an upward push to the wage rate. Okay. So then it makes sense to have money supply rate in this equation because money supply rate is going to have some impact on the wage rate. Okay. So on that note, we can actually include the money supply rate. Okay. So let's name this equation as equation 3. And let's also reduce the screen size a little bit. Now, if I try to now express P in terms of all these error terms and exogenous variable terms, so what I'm going to get here, P I'm going to get UP, UW, and I'm going to have capital U, and I'm going to have M. All right. Now, you see, I have two exogenous variables now instead of one exogenous variable that I had here. Now, which one I'm going to use as an instrument for my endogenous variable W, right? So they're both U and M are indirectly influencing P along with UW. These three variables are indirectly influencing P because all these three variables are coming through this W root, okay? So now, out of these three, of course, these two are exogenous variable, U and M, and both I can actually ideally use as instrument, okay? Now, we have seen that both U is related with W and M is also related with W, and because U and M are exogenous, they are not related with the error term UP. So basically, it's both of these variables are going to satisfy my condition of instrument. So which one I'm going to use as IV? Okay, so that is the question we have. And let's see, let's actually write down the beta to IV if I use each of these instruments, okay? So beta to IV is going to be summation. So this is the equation of price. So Pi minus P bar. And let's say my first instrument is going to be U, which I have been using, Ui minus U bar. And in the denominator, my X is W. So Wi minus W bar and Ui minus U bar. Okay. So we already are quite familiar with the expansion of this equation. So it is going to be, there will be two beta 1, so we cancel the beta 1. So I have, let's say, beta 2, and I'm going to have wi minus w bar into ui minus u bar plus I'm going to have upi minus up bar and ui minus u bar. Okay, and in both the cases I'm going to have this denominator. Let me have one simple line here, and the denominator is going to be summation of wi minus w bar ui minus u bar. So here just note that I have actually substituted the equation for pi, and I basically cancelled out beta 1, and then I've taken beta 2 out of this summation. So if I further basically make it simple, so it is going to be beta 2 plus this term here, and we already know where we are heading, so it is going to be upi minus up bar and ui minus u bar, and then in my denominator it is going to be summation of wi minus w bar into ui minus u bar, right? So we again take a PLIM, and if we take a PLIM on both the sides, so it is going to be beta 2 OLS, beta 2 IV is equal to beta 2, PLIM of beta 2 is beta 2, and then if I basically multiply 1 by n on both numerator and denominator, so essentially I'm going to get covariance of UP and U divided by covariance of W and U, capital U here, right? So the denominator W and U, of course, we have seen in the previous equation that U is influencing W there in the regression equation, U is the regressor, so that is not going to be equal to 0. So I'm fine with this. Denominator is not equal to 0. Whereas the numerator, we have seen UP and U, they are not related, so this term is going to be 0. Okay, so that means beta 2 IV, if we see it is unbiased, and at the same time when n tends to infinity, I'm going to get this, if I use a PLIM rule, so beta 2 is going to converge, beta 2 IV is going to converge to beta 2. B2 IV is going to converge to beta 2. So then basically my properties of IV is being satisfied. Okay, now so that's basically for U as an instrument. Now what will happen if I take M as an instrument? Let's see that. Beta 2 IV, now this time I'm going to estimate beta 2 IV with M as an instrument. So it is going to be summation of Pi minus P bar, this is a price equation, and instead of U I'm going to write Mi minus M bar, right? And at the denominator I'm going to write, my W is the X variable, so Wi minus W bar, and then I'll multiply Mi minus M bar, right? Now we have seen this previous equation, so I'm not going to repeat the step 2. I'm straight away going to step 3, which is basically beta 2 plus summation of, I'm going to have small upi minus up bar into mi minus m bar, right? And in the denominator, I'm going to have the same terms as it is, wi minus w bar into mi minus m bar. Now, if I take a limit on both the sides, so basically what and basically multiply 1 by n on both numerator and denominator. So basically I'm going to have PLIM beta 2 IV. So this is basically going to be beta 2, and I multiply both 1 by n numerator and denominator. So I basically get the covariance of UP and M, and in the denominator I'm going to get covariance of W and M. So covariance of W and M is not equal to 0 because wage rate is related to the money supply. So I'm fine. And here the UP and M, they're not related. They're not related. So I'm going to, so M is coming from the third equation and UP is coming from the first equation. So they're not related. So I can write this equal to 0. So essentially what is happening is B2 IV is basically an unbiased estimator of beta 2, and for large n, B2 IV is converging to beta 2. Okay, so in both the cases, what I'm going to see is that they're basically satisfying the properties of instrumental variable. So I can use either M or U for the determination for basically for our first regression, where I will use them for W instead of W. Now, which one to do that? Which one to use? So one criteria could be we can simply see which one is giving minimum variance and we can use that. But there's another way to sort of identify, like how this both the variables can be used. And in fact, this strategy is to use both the variables. Okay. So what do you do instead of using one, uh, instrumental variable? What do you do is we actually use both the instrumental variable. All right. So what you do there is here what we have done, we in the IV regression we simply took one IV. Okay. But here what I am going to do is I will use two IV. Okay. So X is going to be a linear combination of, let's say, H1 H2 Z2 plus H3 Z3, and let's say some error term. So why I do that? So essentially this is simply going to be an OLS regression, and I do that because actually this is a better combination instead of just using one IV. Okay, and all we need to do is to get a good R square. We have to ensure that we get a good R square, and we also try to see other properties of regression satisfies. For example, we want to get a less, minimum sort of, we want to reduce the residual sum of square and so forth. So that is how we can actually combine both the instrumental variable when we regress them on this regress for this endogenous variable. All right. So this is the strategy, and we'll see. With this, we'll end this lecture here. So we talked about both the over-identification or under-identification problem. So for over-identification problem, what do we do? We use both the IVs in the first stage regression, and under-identification problem, we basically do not have a good IV. So perhaps it is a good strategy to find a good IV, and when you have exact identification, we are fine. All right. So with this, we end this lecture here, and in the next lecture, we're going to talk about the regression strategy when we do this first stage regression and the reduced form regression, and we'll see this two-stage least square method in the next lecture. So with this, we end this lecture here. Thank you.